Alright, let's look at number 5 on our sample exam. It says given an orthonormal set, so we know that they are orthonormal, express this vector in terms of set. So there are two-dimensional vectors here, and so we should be able to express any vector in 2 dimensions in terms of this set. So how are we going to do this? Well, we don't need a reciprocal basis set because they are orthonormal. So we can just use our inner product with the vectors themselves. So we're going to write, we want to write z is equal to something, some a times x1 plus some b times x2, and what we really want to know are what are a and b. From our the way we do this, our method, a, we take, for the coefficient of x1, we take the inner product of x1 with our vector we're expressing in terms of this basis set. So inner product of x1 with z, that's x1 conjugate transpose times z. And so x1 was 1 over the square root of 2 and 2 negative 1s. Okay, so here's x1, and then we have to multiply by z, which was 4, 8. And so we're going to get 1 over the square root of 2. And we should come out with just a scalar number here, so we're going to get negative 4 minus 8, and so we're going to have negative 12 over the square root of 2. Okay, maybe not a very pretty number, but it's a number. B, same kind of process. We want the coefficient of x2 now, and so we take inner product of x2 with our vector z. x2 is 1 over the square root of 2 and negative 1, 1, and z is 4, 8 again. And so we get 1 over square root of 2 times negative 4 plus 8, and so that looks like 4 over square root of 2. And so it says express a vector in terms of the set, so I would say the answer would be then that z is equal to negative 12 over square root of 2 times x1 plus 4 over square root of 2 x2. So I've expressed z in terms of my set x1 and x2. Alright, so that's the end of the test.